Yeah, this question is asking use direct integration to find the Fourier transform for the signal in problem 3.2-1 ABC. And here we have rectangular. This sign represents rectangular and this one triangular and again rectangular. So we are going to deal with rectangular function and triangular function. So first let's look at the equation. Let's deal with the A part. In the A part we have rectangular 3t by 4, and let's call this one x of t. And Fourier transform of any function can be calculated using a formula. Fourier transform. Okay, so let's say Fourier transform is x of omega. I'm taking in terms of angular frequency. Then the equation is negative infinity to infinity, and then the function x of t, and then we multiply this one with e power minus j omega t dt. Okay, and x of t, the given x of t is x of t. It's a rectangular 3t by 4. We can also mention rect 3t by 4. Okay, so when we do the integration, we have to know the interval. And usually for a rectangular function, we take the interval from negative half to half. So in this case, let's say 3t by 4 is in between negative half and negative half and half. Then what will be 3t will be 3t is basically, if you bring this 4 and multiply both sides, that's going to be the interval. So negative 4 divided by 2, that's negative 2, and in this side negative positive 4 divided by 2, that is 2. And if I find the limit for the, you can say range for the t values. If I bring the t to this side, that's going to be negative 2 by 3, and here 2 by 3. This is going to be the interval we are going to do the integration. So therefore x omega is going to be equivalent to integration negative 2 by 3 to 2 by 3, and then at the time 1, and e power minus j omega t dt. And if you do the integration for this, you're going to end up with e power minus j omega t divided by the power without the coefficient without the t. So this is going to be minus j omega, and then the range goes from negative 2.3 2 by 3 to 2 by 3. And if you express this one in terms of sine, this is basically 2 by 3 sine omega times 2 by 3. Okay, that's the answer for the A part. Now let's look at the B part. In the B part, we have a triangular function and then 7x over 10. Triangular 7x over 10, and then that's equivalent to triangular 7x over 10. Okay, now here also we have to find out the interval. For the triangular, we take the interval from -1 to 1. So in this case, the function is 7x over 10. Okay, so to find out the x interval, you have to just, if it you have to treat it like equal, like if it -1 equals 7x over 10, then what is the x1? X is basically minus 10 over 7 in this case, and then the here x, and then same goes here. This is 10 over 7. So this is going to be our interval. Now the Fourier transform, as we seen before, the equation for the Fourier transform will be x omega integration negative infinity to infinity, and whatever the function we have here, that is x of t, and then that one multiplied by e power minus j omega t dt. Okay, in this case our limits of integration is negative 10 by 7 to 10 by 7, and the function we have is uh, this is 1 for the x of t, then 1 times e power minus j omega t dt, and if you integrate this one, this is going to be e power minus j omega t divided by minus j omega t, not t here, with this one the denominator without t, and that is the range is negative 10 by 7 to 10 by 7, and that is equivalent to 10 over 10 over 7 sine omega 10 over 7. Okay, similar to this, you see when we convert into sine, that negative will go away, and then we will have the exact the limit we will have, and inner also we will have the same limit. Okay, now the last part we are going to deal with is another rectangular function t minus 1 over 4. So C part, rectangle t minus 1 over 4. We can write it as rectangular t minus 1 over 4. Now for the rectangular, we take the interval from minus half to half. This t minus 1 over 4 is between minus half and half. Okay, this is t minus 1 over 4. So what we have to figure out what's going to be for the t. So for the t, if we bring this minus 1 over 4 to this side, this plus 1 over 4, then if I want to convert this on the same denominator, this is minus 2 over 4. So 1 over 4 minus 2 over 4, that is minus 1 over 4, and then t here, and if I bring 1 over 4, if I add 1 over 4 to this side, this is 2 over 4 plus 1 over 4, that is 3 over 4. So here the range is going to be minus 1 over 4 to 3 over 4. Now we know the Fourier transform equation, that is given by x omega is equal to integration negative infinity to infinity, and whatever the function we're going to integrate comes here, and then multiply by e power minus j omega t dt. And in this case what we have, the height is 1, and e power minus j omega t, the interval is minus 1 over 4 to 3 over 4. 3 over 4, this is j minus j omega t dt, and if you integrate, you will end up with e power minus j omega t divided by negative j omega, and the interval is from negative 1 over 4 to 3 over 4. One is 3 over 4. So finally we have to just plug the values for the t. So if we do that, this is going to be e power minus j omega times 3 over 4 minus we are going to have the same denominator for both of them, so we can keep it as it is. And then here we are going to have e power minus minus become plus, so this is going to be j omega over 4 divided by minus j omega, and that's our final answer for the C part. And that's it for this video. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.